Hey, welcome to lesson 6.3, Properties of Rhombuses. Today we're going to be talking all about rhombuses, so get ready because I know they're your favorite parallelogram because they're actually mine. So before we get started, I just want to talk to you about the different kinds of quadrilaterals we're going to be talking about. We're really diving in deep to quadrilaterals, which are four-sided figures, and there's different kinds of quadrilaterals. Now, there's a good analogy I have for you while we talk about quadrilaterals is animals. Okay? There's many types of animals out there, and two types of animals would be cats and dogs. Now, cats and dogs are very different things, but you would both call them animals, right? You could both say that they're an animal. Now, there are different kinds of cats too, right? We have Garfield, who's a cat, and Felix, who's a cat. So both Garfield and Felix are cats. They're not dogs. And under dogs, we have Odie, and Odie's a dog. Now, all of these things would be considered animals because they're all under the animal symbol, and anything under the cats would be considered a cat. That made sense, right? Now let's move over to types of quadrilaterals. Now there's different kinds of quadrilaterals. There's parallelograms and trapezoids. Now there's many different ones, just as there's different animals than cats and dogs. But the two that we're really going to focus on are parallelograms and trapezoids. Now, there are different kinds of parallelograms also. Just as there's different kinds of cats, Garfield and Felix, there's different kinds of parallelograms, such as rhombuses, rectangles, and even squares. All right? There's also trapezoids, which is a quadrilateral, but is not a parallelogram. And we'll talk more about trapezoids and the different kinds of them. But what I really want you to know is this. Rhombuses, rectangles, and squares are all different kinds of parallelograms because they're different kinds of quadrilaterals, okay? But these all fall under the category of parallelograms. That's it. They're in the same family. They're like cats or something like that. All right, moving on. Today we're going to talk about rhombuses. And as we said, rhombuses are all parallelograms. And since a rhombus is a parallelogram, it shares all the properties of a parallelogram. And let's go over our 5 properties of a parallelogram again. 1, opposite sides are parallel, right? That's our first property of a parallelogram. Opposite sides are parallel. That is true for every parallelogram, so that is true for a rhombus as well. Okay? We also know opposite sides. And by the way, if you know these already, feel free to write them in and fast forward me. You don't have to listen to me say this. Opposite sides are congruent. All right? And so we know the opposite sides are actually parallel and congruent to each other. We know opposite angles. Angles are congruent. All right? And that's the symbol for angles. That's the symbol for congruent. So opposite angles are congruent. Just like so. They're across from each other. We know adjacent angles are supplementary. And finally, we know diagonals bisect each other. Diagonals bisect each other. Each other. So these are all facts we know about parallelograms, and since that's true for all parallelograms, that's true for rhombuses as well. So keep these in mind. These are true for all the rhombuses we're going to be talking about because they're all parallelograms. Going back to this chart, see, rhombuses are parallelograms, so they share all the features, just as cats, Garfield and Felix are cats, so they all share the cat properties like ears, the tail, fur. Now, rhombuses are definitely special. They're different than other ones, and there's 3 main properties that make them different. All right? Now, the first one we're going to talk about is this. We know that the diagonals in a rhombus bisect the angles. Okay, so here are our diagonals, and these bisect the angles. Diagonals bisect angles. Now, what's bisect mean again? That means cuts in half, right? So I know that this diagonal right here will cut this angle into 2 congruent pieces. All right? And this will be the same 2 congruent pieces because the angle is congruent. So these are both congruent. And this diagonal over here cuts this angle into 2 congruent pieces. So these are all congruent. All right? So the diagonals bisect the angles, which is different than bisecting each other. Okay? It bisects the angle. but they also bisect each other. 2. The diagonals are perpendicular, okay? The diagonals are perpendicular, and that's the sign for perpendicular. Perpendicular to each other. What's that mean? Well, let's draw it out. That would help us out a little bit. Let's draw this out. So we have our diagonals, and in a rhombus, the diagonals form 90-degree angles, okay? So every angle in the middle over here, this angle, and this angle, and this angle, and this angle are all 90 degrees, all right? So they intersect to make 90-degree angles, just like so. Okay. And finally, this is the main one about rhombuses that everyone knows. Well, maybe not everyone, but we know now. And this is the easy one. All sides are congruent. Why did I draw diagonals? All sides are congruent. In every rhombus, every side is the same length. So that's not true for parallelograms, all of them, okay? Not all parallelograms have every side the same. That's like what really makes a rhombus special. All sides are congruent, diagonals bisect the angles, and diagonals are perpendicular to each other. All right, let's see if we can use these properties to solve some problems. Okay, starting here. Quadrilateral ABCD is a rhombus. Fill in all missing sides and angles. Well, I think we can handle that. Well, let's start with the angles. If you remember last time, we know opposite angles are congruent, and since this is a parallelogram, we can say that this is 110 degrees, because opposite sides are congruent. And then we know adjacent side angles are supplementary. So to find this angle over here, we just have to do 180 minus 110, and that gives us 70 degrees, which is this angle. And once again, opposite sides are congruent. Opposite angles are congruent. Good. That was pretty straightforward. Now the sides is the easy part because we know all sides are congruent. So if we know one of the sides, such as AD is 5 inches, we can say that every other side is also 5 inches. This is 5 inches, and this is 5 inches, and this is 5 inches. Okay, so let's spell out our answers. Side BC, which is over here, that is going to be 5 inches. AB, which is the side over here, will also be 5 inches. Angle B, which is over here, is 70 degrees. And angle C, which is over here, is 110 degrees. Sweet! Moving along. IJ is a diagonal rhombus HIJK. Mark all congruent angles and find the measure of the missing angles. Fair enough, we can do that. Let's start over here, okay? This angle and this angle. Well, what do we know? We know that this diagonal bisects the angle, meaning it cuts into two congruent pieces. So if this is 35 degrees, we also know this is 35 degrees. All right? Now you might remember that since this is a parallelogram, we have this line HI and KJ. These are parallel to each other. And this line, our diagonal KI, would be considered the transversal that cuts in half. So if this is 35, we know that this angle is also 35 degrees because they're alternate interior angles. They're on the inside of these parallel lines and they're on alternate sides. And once again, because we know these two angles are congruent, because the diagonal bisects the angle into two congruent angles, that's also 35. Now let's get rid of all this extra jazz right now, and I'm just going to, let's fill those angles in. So these are all 35 degrees. All right. Now what I'm trying to do is find out what H is now. And the way to do is this. I know that this whole angle minus 180, because these two are supplementary, will tell me what angle H is. So if I do 180 degrees and I subtract these two, which are basically what add up to whole angle K, that will tell me what H is. So 180 minus 35 gives me 110 degrees. So H is 110 degrees. And does that even make sense? Well, let's look at that. H is 110, right? And these two angles, if you add them together, are 70. 35 plus 35 is 70. So if I add those together, I get 180. And so the whole angle K plus H should be supplementary. So we, oops, I hate when that happens. All right, so now we just got to find what these angles are. Let's start with, I don't know, H. That looks like an easy one. So H, which is right here, we know that's 110 degrees. All right. IJK, which is over here. IJK, J is our vertex. IJK is 110 degrees. HIK, so if I do it, HIK, which is right here, is 35 degrees. That goes right down like this. I hope you guys are tracing this as well. It'll help you a lot. HIK, which will show you where the angle is. And then angle K. Let me get rid of all this jazz. It's getting a little overwhelming. All right. Angle K. Just want to look at this real quick because it's kind of an interesting part of this. So we knew that this is 35 degrees. Now angle K is the whole thing. So how do we find out what K is? Well, we just add up 35 plus 35. So if we add them, 35 plus 35, that's 70 degrees. All right. Let's keep rolling. Diagonals NP intersect at point H of rhombus PMNO. Mark the congruent sides and angles and find the measures of the missing angles. Sure enough, I can do that, okay? Congruent sides, boom, 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 boom. Congruent angles, well, we know this and this are congruent, and so is this and this because the diagonals bisect each other. We could also assume that these are all congruent too, right? Because these opposite angles are congruent. Now let's just start filling in. So if this is 40 degrees, all right, we know this is also 40 degrees. And we know this is 40 degrees. And we know this is 40 degrees. Okay? Now how are we going to find this angle over here? And this is an interesting question. What we're going to do is start by finding the whole angle M. And as we did in the last problem, what we're going to do is take 180, because we know P and M are supplementary, and we're going to subtract those two 40 degrees from it. All right? And that gives us 100. So the whole angle M is 100 degrees. But that isn't enough because we see that it's split in half, and this diagonal bisects it. And since this is a rhombus, we're just going to have to divide it into two. So if we take 100 and we divide it into two, we know that this part is 50 and this part is 50. And once again, let's see if this makes sense. P and M should be supplementary. So if I add 50 plus 50 plus 40 plus 40, I should get 180. So 50 plus 50 plus 40 plus 40, that should be 180 degrees. And sure enough, that's true. Now once again, these are also 50, 50, and 50. And that's how it's done. Now these I'm going to have you fill out all by yourself. But there's one that I want to look at with you, and it's this. We know that we want to find PHM. All right, that's this angle right here. PHM. And we want to find out what that angle is. And this angle over here, it's 90 degrees. We know it's 90 because diagonals intersect to create 90 degrees. So any angle in the middle will be 90 degrees like that. PHM is 90 because diagonals intersect to create 90-degree angles. Okay, we're going to use the properties now to really start solving some algebraic problems. Ooh, let's move this over a little. ABCD is a rhombus. Solve the following problems and state the problems used to solve it. So the rhombus tells us a few things. It tells us that all the sides are congruent, and it tells us that the angles bisect each other. So how are we going to solve this? Well, let's take a look here. To solve for angle x, we know that we have these two parts of the angle, this angle and this angle. All right? And what do we know about these two angles? We know that they're congruent. And how do we know that? Well, the property that lets us know that is that diagonals bisect the angles, right? So that means that it cuts into two congruent parts. So to solve this, when I know two things are congruent, I just set up my equation as 7x minus 2 is equal to 5x plus 3. And that's all you got to do. Now, if you solve this out, I'd like to see you guys do this, but I don't want to spend too much time doing the algebra. what you should get is x is equal to 2.5. All right? You try the algebra yourself, that's what you should get. Now to solve this problem, solving for y, we have our sides over here. AB is equal to 2y minus 7, and BC is equal to 5y minus 28. Now what do we know about the sides? We know that all sides are congruent. And if all the sides are congruent, once again, I know how to set up this equation. It's simply 2y minus 7 is equal to 5y minus 28 because they're congruent. If I solve this one, I should get y equals 7. All right, final question. IJ and HK intersect at point L in rhombus HIKJ. HL equals 6 and LI equals 8. Find the length of HI and state the property used to solve it. Well, they didn't draw our diagonals for us, so let's do that ourselves, okay? We got HK and JI. We're going to draw these ourselves. You should be drawing it with a protractor. And we got angle L right here. We know HL, which is right here, is equal to 6. And we know LI, which is right here, is equal to 8. We want to find HI, which is this side right here. Now, what property can we use to solve this? And I'll tell you. We know that this angle is 90 degrees, right? Now, you might be noticing it right now, but how does that 90-degree angle help us? Well, that tells us that this is a right triangle we just formed, right? So the property we use is that diagonals are perpendicular. And when we have a right triangle, we know we can just use the Pythagorean theorem to find the third side. And so since the hypotenuse is the unknown, we could set up as 6 squared plus 8 squared is equal to c squared. We don't know what HI is. 6 squared is 36 plus 64 is equal to c squared. 100 is equal to c squared. Take the square root of both sides and we get c is equal to 10. Boom. Now you'll see that there's this bonus question right here. What's the perimeter of HIJK? Well, if I know that's 10, I know all the sides are 10. And to find the perimeter, I just add it all up to equal 40. Now the cool thing is, if you're on pace, you should have just passed Christmas right now. And that looks like a Christmas tree. So guys, I hope you're loving your parents and your family, or gave them a lot of love this Christmas. And sorry this video was so long. Peace!